Okay, welcome to section 2.7, which is regarding measures of the spread of the data. Okay, 2.7 is the last section of the chapter, so that we will cover. So go ahead and just on the syllabus you can cross out that 2.8. Okie dokie, let's get going. So let me start by introducing first standard deviation and variance. Okay, so we're going to do an example to talk about what is standard deviation and how does it inform us about the data set. Okay, so it's best illustrated with this example. So, okay, so let's suppose we have this person, Jasmine, and she has this many close friends. She has about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 close friends. And if we took the mean of her close friends' ages, the mean is 41.5. So the average age of her friends is 41.5, and every friend is either older than the average or younger, okay, or maybe almost the same. In other words, the ages deviate from the mean age, right? It's either a little more or a little less or the same. And so the question is there a number that we can calculate that gives us a measure for the overall deviation from the mean? And the answer is yes. So it's basically like we take all this data and we have the average, and we want to know how far apart is it stretched out overall, okay? And so you can actually, we're going to build up to that, okay? And we do this the standard deviation. But this is the beginning, okay? So let's say here are the friends, okay? We don't know their names. It could be anybody. And in order to calculate the deviations from the mean, let's suppose we go ahead and we subtract the mean from each one of the ages. So, 41, the friend's age is 41. 41 minus 41.5 would be negative 0.5, and then 38 minus 41.5 would be, so basically the deviation in this case, we're talking about the difference between every data point and the mean, okay? So if we were to add them, let's say we wanted to take the average of the deviations, we would get a problem, because we would run across a problem because you see here there's negative and there's positives, and the sum of all of these will always be 0, okay? They will always be 0. And I'm not going to get into why exactly, but let's just say that it's not that simple where we can just subtract each data value from the average and then take the averages of those differences. So we have to do a little bit more first before we do that. So let's say, okay, well, what if we square the deviations? Okay, so why? Who cares? Like, why should we do that? Well, the result of squaring the deviations is that every single negative number will now become positive. So if you take a second and just observe here. So see how the first difference was negative 0.5. We square that, that's 0.25. So now we have here this list of positive deviation squared, okay? So if we add these together, right, we take the average of these squares, so we add them all together. Remember the lesson about this weird sigma, capital sigma means to add all of them together, all of the deviations squared together. We get this 88.5, and we divide that by the total number of numbers, right? In this case, our population size, and we get 8.85. So this is called the variance. We call this number the variance. So when we do this, so basically we've just kind of created the variance of the ages. Okay, so it's an overall measure, right? So square ages is still a little bit different, right? It was, the name changed. I guess it's Juan now. So, but if we squared this, are we really being completely accurate? Because we ended up finding, the sum of the squares, and then we took the average of the sum of the squares. So that's kind of what this is. We call this the variance. So if we wanted to be something a little bit more accurate, we would take the square root of this, okay? We take the square root of that. It kind of helps offset the squaring that we did initially, and we would get this number 2.97. And this number, see how this crazy equation, it looks super crazy, but now that you know how we got to it, it's really not that crazy. This is called the standard deviation, and this is kind of how we measure how far apart are the data from the mean. Okay, so this is the formula for standard deviation. Okay, so again, you remember box plots, how 1.5 IQR away from Q3 and 1.5 IQR away from Q1 are kind of fenced in the data, and anything outside of that is considered an outlier. So we kind of have something a little bit similar when we talk about standard deviations. Would say, okay, well, for a list of data, most of the data, a high percentage of the data will be contained within 2 standard deviations of the mean. So let me restate this in a different way. So, okay, so like for example, here in this instance, the mean age of Jasmine's friends is 41.5, yeah? So then we calculated the standard deviation to be 2.97, okay? So think of a standard deviation as like a fixed distance, okay? So it's like a fixed distance. So if we add 2 of them, so see how let me take out my cool little pointer thing. Okay, if we add 2 standard deviations away from the mean, okay, we get this upper bound value. And if we subtract 2 standard deviations from the mean, we get this lower bound. And observe, okay? Actually, all the data is contained within this interval, right? So all the data in this example, it's all contained. That's not always going to be the case, okay? But in this specific, all right. Now that was considering her friends, her close friends. She only has 10. She has no other friends at all. She's not on social media, nothing. She only has 10 friends. It's okay. That you would consider that to be a population standard deviation. And it's really important that you can tell the difference, because these little symbols, they all have meaning. So when you're talking about a population, so let's remember what's the difference between population and a sample. Population is we're talking about everybody in the situation, and a sample would be a small subset of that. Okay, so in this case, we're thinking about friends. Let's say that list of ages, that's the only friends she has. There are no other friends. So that would be the population. We would consider that her population. However, let's suppose that she was active on social media and she had, let's say, thousands of, internet quote unquote friends, right? That's debatable. You can consider them friends or not. I don't really know. But let's say that she did consider them friends. Then those 10 people that we took data on would be a subset. In other words, a sample of the population, yeah? So we would use this equation here. So when we take the average of the squared deviations, we would divide by n minus 1. And so the sample standard deviation is a little different. But remember, x bar is the same. It's the mean, but the sample mean. Mu is also the mean, but it's the population mean, okay? And then capital N is the size of our population, and then little n would be our sample size, okay? So this S here means sample standard deviation, and then this sigma here would be population standard deviation. Okay, so so why do we divide by n minus 1? And it has to do with the population variance. Since this is an estimate of the population, there's a lot of math behind that. I'm not going to bore you with it, but let's just trust that. I mean, if you really want to know, we can talk about it apart from this video, sure. send me an email. We'll talk about it. But just know that when we're calculating sample standard deviation, we use this n minus 1. And that's exactly what we said here. So if she had thousands of social media friends and the list of ages were a sample of her friends, we would have to modify our calculation, right? So our calculation would be, instead of dividing by 10, we would divide by 9, and then her variance, sample variance, would be 9.83, and her sample standard deviation would be 3.14. Okay, so now we know how to do it by hand. But of course, remember I told you in the beginning of the course, we're going to go through some complex calculations, and then boom, I'm going to show you how to do it on your calculator, and then you're going to say, why did we go through all that in the first place? And I'm going to respond by saying, this is important, you know, you just need to see the process to help you understand the concept. All right, so, so now let's go over, how do we do this with the TI-84? Well, it's the same thing that we've been doing all this time. This will be about the 7th time, I think, that we've gone over creating a list. Okay, so stat 1, edit, right? We create a list. If you're still stuck on how to do this, go back to a previous video. I think it's, I go over this. I think even in the last video, I go over it. Okay, so then when you enter it in, stat calculate, one variable statistics, here's your sample mean, here's your sample standard deviation, and there is your population standard deviation, okay? So we really didn't have to do all of that, but I think it was good for us to do it just to see how it was developed, okay? Yeah, and then if you want the variance, you would just square these numbers, okay? All right, so here we have here, let's suppose we want to have, we have this data from Susan Dean's pre-calculus class, and let's say we want to create a chart containing data, frequencies, relative frequencies, and cumulative relative frequencies to 3 decimal places. And then let's say we wanted to calculate the sample mean, sample standard deviation, median, first quartile, third quartile, IQR. And then let's say you want to construct a box plot and a histogram on the same set of axes, and let's talk about, let's interpret interpret the chart. So if I were you, you know, I know you want to really like maximize the time that you spend watching these videos and doing the work. This is where in class I would say, okay, everybody, let's do this together. Let's write this out. Let's recall what relative frequency is. Let's recall what frequency is. Let's recall what CRF is. And then go ahead and do that. So if you have the time, do me a favor, push pause, go ahead and see what you can do on your own first, and then watch the rest of the video so that you can kind of have that assurance, oh yay, I was totally on track, or wait a minute, I wasn't. Okay, so I'll give you a few seconds to pause. Okay, great. So at this point, I'm assuming that you did pause and you tried it. Way to go. Let's look at the solution, okay? All right, so this is in decimal form. You could have done this as fractions. And if you had done this as fractions, you would have here the sum of this would equal 1. But in this case, it does not add up to 1. It should add up to 1, but it doesn't because we are, because of rounding errors, you know, because this is an exact, okay? So that would be one thing. And let's see, so what else can I say? So yeah, so go ahead and check your work. Remember, cumulative, it just adds the ones before it, right? So these two, 6.4, 6.4 plus 6.5 is 0.129, and then so on. It keeps adding. And then the last one should be 1 exactly, right? But in this case, because of rounding, it's not. Okay, so if you didn't get 1 because you were using decimals and not fractions, it's fine. You're all good. Don't worry about it. Okay, so the next thing for us to do is to calculate the statistics, right? The sample mean, the standard deviation, median, first quartile, third quartile, and we know how to do that. Right? We've gone through this. We've gone through how to do this. We've gone through how to do that, and as well as creating a box plot and a histogram. And you can do this simultaneously, and I'm going to illustrate that in a video right now, but I just want to show you really quickly how we did that. You know, you would select plot 1, histogram, select plot 2, box plot, and then the window, you've used this window here, so 32.5. How we're going to go ahead and calculate the sample mean and the sample standard deviation, median, first quartile, third quartile, and the IQR. So actually, we've already done this multiple times. When you go stat, edit, enter, then you have your list. I saved a little bit of time. I put it in there already. And then we go to stat, calculate. Okay, one variable stats, hit enter. Frequency list is actually not L2 this time, right? So nothing, it's just all in one list. And so then we hit calculate, and there it is. So you have your sample mean. This S of X is your sample standard deviation. Your median is 73, and then you have your first quartile is 61. Your third quartile is 90. So from this, you could tell me what your IQR is, which is of course a difference. So your IQR is, go ahead and tell me. I'm waiting. Okay, if you said 19, good job, because that's what it is. Okay, then the second part is to graph a histogram and a box plot. So you would go here to stat plot. And so you would turn both of these on, okay? So then when you go into stat plot, the first one, really doesn't matter which one you do first, but in this case, I went ahead and we turn plot 1 on. We select the histogram. So the histogram is this third option. XList is L1, frequency is 1, and then we're ready to go. And then we need to go ahead and make sure that we enter the second plot, which is going to be our box plot. So you go inside, make sure that it's turned on. You make sure that the box plot icon is highlighted. And then we make sure that L1 is your XList, your frequency is 1, and then there you go. And then the last thing would be to make sure that your window is good. So there are some, the X scale is 13.6. We want there to be 5 bars. Our minimum is negative 2.4. Our max is 17 on the Y scale. And then we have here X max is 100, X min is 35, and that's just to keep the range of the data, right? X min actually should be 32.5, right? Sorry, I don't know why it says 32.5. Okay, so then let's look at the graph. Hopefully this came out okay. And there you go. Oh, interesting. Why are both blue? So let me go to the second one, and I'm going to turn this to red because I want it to be just stand out a little bit. We have other colors. Oh, magenta. Ooh. Wow, there's so many colors. I never really... Why is there so many types of gray? Okay, well, let's just do red, okay? And, yep, so our window, let's make our Y, I don't know, negative 2.4, maybe 18. Let's see what happens. Okay, graph. Okay, and there it is. So then you see here 1, 2, 3, 4, 5 intervals, and okay, so let's interpret that. So let's see here. We have in the box plot, we have a long left whisker, okay, and we also can say the spread of the exam scores in the lower 50% is greater than the spread in the upper 50%, right? So, and then you can see that here, the histogram and the box plot and the chart all reflect this. So there's a lot of A and B grades, 90s, 80s, 100s, and then you can see that here. And then we have here the middle 50% of the exam scores are the middle 50%. The IQR are D's, C's, and B's. And the box plot also shows us that the lower 25% of the exam scores are D's and F's. Okay, so here, what else? Okay, so then again, so how do we do standard deviation for grouped frequency tables? So first of all, you might think, well, what's a group frequency table? Remember from last time, it's basically when we have, we don't know the individual data values, so we can't do exact mean, median, or mode, but we could do, we could use this formula, okay, when we calculate the midpoints. And then remember here, so here's an example of a grouped frequency table because it's given in intervals. So you have 0 from 2, there's 1, 3 to 5 is 6, 6 to 8 is 10, 9 to 11 is 7, and then here you go. And then we just take the midpoints. So we take the midpoint of each interval and we enter that into L1. So the midpoint between 0 and 2 is 1, between 3 and 5 is 4, between 6 and 8 is 7, between 9 and 11 is 10, between 12 and 14 is 13, and so on. And then we go ahead and write their frequency, and we do just like how we did before, except that remember when we do first one variable stats, we do frequency is L2, okay? So that's that. Okay. And then the last topic is we're starting to introduce z-scores at this point. Okay, so standard deviation is useful when you have, you're comparing data values from different data sets. However, if we have, if we have different means and different standard deviations for the data sets, then comparing the data values just directly, it could be misleading. So that's why we use the standard deviation to calculate what we call a z-score. In other words, for each data value, we're basically calculating how many standard deviations away from the mean its value is. So we're basically, instead of counting the actual physical score, right, we're saying, okay, well, how many standard deviations away from the mean is this score? And then when we do that, that number, the distance, or in other words, the number of standard deviations away from the mean is called a z-score, okay? So we're going to keep seeing that. So here's the formula. Okay, so when you have you have a sample value and you want to convert that value to a z-score, we subtract the mean, the sample mean, divide by sample standard deviation, and that's your score. And if we're considering a population, you would subtract the mean, mu, and then divide by the population standard deviation. Okay. So of course we need to do a super fun example to illustrate this. So suppose you have two students, John and Allie, from different high schools, and they wanted to find out who had the highest GPA when compared to his school. So how would we do that? They go to different high schools. So John has a GPA of 2.85 when the school mean is 3.0, and the standard deviation for the school is 0.7. Allie's GPA is a 77, but the mean GPA is 80, and the school standard deviation is 10. So we go ahead and we calculate the z-scores for each. So see, here's my values. So 2.85 and then 77. Let's subtract the mean away from each. So 3.0, so subtract, we find the difference. Okay, and then we finally divide by the corresponding standard deviation. So, you know, we divide that. So John has a z-score, his GPA has a z-score of negative 0.21. And Allie's has one of negative 0.3. So John has a better GPA because his GPA is less, like it's negative, it's 2.1 standard deviations below the mean, while Allie's is 0.3 standard deviation below the school's mean. Okay, and here's your homework, and I will see you on the next video. So remember, this is it for chapter 2. We're going to have our quiz soon, so just be ready for that. All right. Go ahead and calculate the sample mean and the sample standard deviation, median, first quartile, third quartile, and the IQR. So actually, we've already done this multiple times. When you go stat edit, enter, then you have your list. I saved a little bit of time and put it in there already. And then we go to stat, calculate. Okay, one variable stat, enter. Frequency list is actually not L2 this time, okay? So nothing, it's just all in one list. And so then we hit calculate, and there it is. So you have your sample mean. This S of X is your sample standard deviation. Your median is 73, and then you have your first quartile is 61. Your third quartile is 90. So from this, you could tell me what your IQR is, which is of course a difference. So your IQR is, go ahead and tell me, waiting. Okay, if you said 19, good job, because that's what it is. Okay, then the second part is to graph a histogram and a box plot. So you would go here to stat plot, and so you would turn both of these on, okay? Then when you go into stat plot, the first one, really doesn't matter which one you do first, but in this case, I went ahead and we turned plot one on. We select the histogram, so the histogram is the third option. X list is L1, frequency is 1, and then we're ready to go. And then we need to go ahead and make sure that we enter the second plot, which is going to be our box plot. So you go inside, make sure that it's turned on. You make sure that the box plot icon is highlighted. And then we make sure that L1 is your X list, your frequency is 1, and then there you go. And then the last thing would be to make sure that your window is good. So there's some, the X scale is for 2.6, we want there to be 5 bars. Our minimum is negative 2.4. Our max is 17 on the Y scale. And then we have here, X max is 100, min is 35, and that's just to keep the range of the data, right? X min actually should be 32.5, right? Sorry, okay. So then let's look at the graph. Hopefully this came out okay. And there you go. Oh, interesting. Why are both blue? So let me go to the second one, and I'm going to turn this to red because I want it to be just stand up a little bit. What are the colors? Ooh, magenta. Ooh. Wow, there's so many colors. I never really. Why is there so many types of gray? Okay, well, let's just do red, okay? And, yep, so our window, let's say, let's make our Y, okay, graph. Okay, and there it is. So then you see here, 1, 2, 3, 4, 5 intervals, and there's your box plot.